Hello, my name is Suau, and I'm the Chief Business Officer at Sinclair Digital. We're a supplier to the low voltage and electrical contractor world of packaged infrastructure for digital building solutions. And with me, I have Ronna Davis and Jeff Beavers. Please introduce yourselves.
Yeah, hi, thanks Louis. My name is Ronna Davis, and I'm the Chief Revenue Officer at Voltserver. Voltserver is the inventors of fault-managed power.
Good afternoon, I'm Jeff Beavers. I'm glad to be here. Thank you, Louis and Ronna, for letting me join you. I work for the National Electrical Contractors Association. I'm the Executive Director of Network Integration and Services. Louis, I represent like the low voltage side of the industry, or the telecom or voice data video, whatever it is called across the nation.
Awesome. So our topic here today is AC versus DC and the future of electricity. So let's take the Wayback Machine 150 years ago, and there was a battle between AC and DC, and AC won, and so the whole world deployed AC technology, and over time the telecommunications world picked up DC power, and obviously our phone systems were powered that way, and over time networks started, IT networks, as they evolved, and telecommunication systems started using DC power. So what's really changed over time?
Well, I guess from my perspective, as like I said, Voltserver is the inventors of fault-managed power, which is a safe to interact with higher voltage DC power. So those DC technologies that have been proliferating through the building have primarily been low voltage DC, which is safe to interact with. A lot of them are connected smart systems. And I think one of the biggest changes is the advancement of fault-managed power, because now there is a higher voltage power that is also a connected system, a smart system, but it's safe to interact with. So it installs and behaves a lot like those other low voltage DC systems that we've been using for quite some time in the building.
So let's dig into that a little bit. What makes fault-managed power safe?
So digital signal processing. So fault-managed power is a digital technology, and we transmit our power in packets. With each one of our packets, we have a safety check. It goes out and monitors the line. If there's any sort of decay or a fault on the line, it doesn't send the next energy packet, and that limits the amount of energy into any fault, where that would cause electrocution, excuse me, or a fire hazard.
Great. And Jeff, from the labor side of things, what is the attraction to fault-managed power?
Yeah, the attraction, I think one of them is a takeaway I hear from Ronna. It's safer, and the job of the electrician is more dangerous than a police officer. So why wouldn't we all want to work safer with less risk? So that's very appealing. But it's appealing because it's also a rise of low voltage systems, per se. I mean, low voltage is a term, but it's a limited energy. Fault managed power is installed much like PoE and category type cabling. So it represents a shift in possibly who can do that work. And back to your question about going back in time with the AC, DC wars, the telephone and telegraph have been around just as long as electricity, but it wasn't as life-changing as when AC allowed us to power light bulbs and not having to use kerosene, so it was more life-changing. People probably use the telephone to say, have you heard about this new electricity, right? But the telco side has been sending voltage over very small diameter cabling for decades, right? For your 48 volts DC to be able to talk, but also that ring down voltage. So that shift to put it into the enterprise is huge. And I think it's like the AC-DC battle again, except it's a newer, safer form of DC. And so it's fascinating. So I think it's an opportunity for folks like me who came up on the telecom side. It's just another application of the network, voice, data, video, and electricity.
Right. So we know, honestly, buildings have been hybrids, right? So you've had DC in the network side, obviously definitely in the telephony side, and you have line voltage for the rest of the applications. Where's the shift happening? How much high voltage do you think is going to be here 5, 10, 15 years, and what's the trend?
Yeah, that's the only question. It's a viable technology. It's already recognized in the code. The only question is the rate of adoption. I think that, without giving an answer, and I'll wait for you or Ronna to forecast some duration, but when I look at the book, it's 100 years of NECA and IBW, it talks about the history of those AC-DC wars, but when AC was brand new in 1900, they said it started the path for rapid technological advancement. But I say rapid advancement in 1900 is not the same as rapid advancement in 2025. We just saw, for example, I like to use the example of Uber, how quickly Uber changed our behavior and thinking of not getting into a car with a stranger. Seemingly overnight, we just trusted the system, right? But so that was in 2009, and look how quickly it's progressing to driverless car services. We just trust the technology. So I think that, one, being recognized by the code, right, and it continues to knock down dominoes at what it can power. I think that change also happens with brand adoption, the Marriotts, the Circas, the whatever brands are out there. Disney, we heard that presentation yesterday. So when people start seeing those major brands do it, they say, well, if they could trust it, maybe I could trust it too. So it could be 5 to 10 years, just my guess.
Yeah, I think that adding to the conversation around how quickly things get adopted now, I do think this is going to happen faster because there's all of these other things that are happening right now within the industry around, AI, robotics, and virtual reality, augmented reality applications and overlays that will be in our built spaces. And so I think from a timing standpoint, we're in the early adopters right now. The fault managed power or DC powered buildings, and we already have some buildings that are doing that, right? We do have some big hurdles to get over. Primarily education into the market. It's a big one, which I know NECA is working and supporting. Making sure that the installers are trained on the new technology. But I do think that education and outreach into the market, that will take us the longest, right? Once somebody uses fault managed power, they don't go away from it. That's one thing. Voltserver's been around for about 12 years now, and what we do know is that once a customer starts using fault managed power, they just keep looking for more ways to use it because it's so much easier, deploys faster, and it gives them so much better data and control over their power infrastructure. So from a timeline perspective, I think right now it's going to be powering building subsystems and networks. That's where we'll be for the next few years. And then I think we need more devices that can accept either DC or fault managed power at the edge. And we need the right building design processes, I think.
Yeah, Louis, if I could follow up on that, because like an answer that you give me is it depends. It's already adopted.
That's fair.
A lot of IT equipment has already been doing PoE and now fault managed power. So those systems are, it's ripe for that. Telco applications, wireless, DAS, so it's already there and it's proven. And they say it has the reliability that a telco requires, often 5 nines reliability, which is like a minute or two for a whole year. So once that starts happening, you start finding more systems. And now we're encroaching into the OT space, a lot of mission critical things. So I think that with a lot of that awareness, I think happens quicker today than it did in 1900. So again, it's going to be quick. And once people start finding what it can do, they're going to ask what else can't it do in power.
So we're almost out of time, but one last question. When I was at Cisco, a lot of the focus was on international standards. And really, PoE was the first global international standard for power, right?
Yeah.
Right.
Where do you see the role of FMP in creating that standardization globally, and what areas of the world are probably the most challenging today?
Yeah, so I think what's really exciting about fault managed power is that if we do this right, we can follow that path this blueprint that PoE and the RJ45 connector gave us, right? Which is, that is the most successful connector in history.
And now we have USB-C.
Yeah, and so I think if we follow that blueprint, that it will be very, very valuable to globally, right? We're seeing, you know, we've done codification and standardization here in the United States for fault managed power. Canada is working on their codification of the technology, and I'm not quite sure where it sits within Europe and APAC, but we have interest in those markets. Voltserver has installations in the European market and the Latin American market, and so there's an interest in the technology, there's an openness to learn and to work with us, and so our goal is, yeah, let's make it a global standard. I think that that really is super beneficial, especially to large multinational companies that are trying to deploy standardized infrastructure across all of their facilities globally. Yeah.
Yeah, I think that this could be the path towards a global standard because, you know, for all the reasons that Ronna said, but I think there are 15 types of plugs across the world.
Right.
Right, and so imagine if manufacturers could drive this and have one or two plug types and how that's going to streamline the supply chain and force us to say those TV sets or whatever are obsolete because now we only have this one type of plug. So that could drive that. But you're right, IEEE is a global standard, Ethernet's a global standard. If you're in a Marriott property in Tokyo or Temple, Texas, Wi-Fi is the same standard. And so if you look at that, I think it's that C19 plug, which is on like a lot of electronics. I mean, you can output that with fault managed power to PoE or USB-C, and you have a global standard. So I think the technology is there. It's just part of that culture change that sometimes slows. But I think that you could probably force that when you make things obsolete.
Awesome. Well, we're out of time today, but thank you both for participating in this panel session.
All right, thanks, Liz.
So glad to be here. Thank you.